Today we're going to talk about position versus time to velocity versus time graphs. The specific topics we'll cover are the steps that you take to go from position versus time to velocity versus time graphs, and from velocity versus time to position versus time graphs. So to start us off, we're going to think about this scenario. We have Sammy the snail. Sammy the garden snail is at position x. So here he is right here at x equals -1 centimeters. It sees a kale plant that is over at 2 centimeters and it's heading over for a snack. It stops to eat for 3 seconds. Feeling full, it heads back out of the garden. So let's think about it in parts. He starts at -1 centimeter. So here he is at time 0 at -1 centimeter. Then he's going to travel to 2 centimeters. He's going to stop and eat, and then he's going to travel back out of the garden. So we'll show it one more time with an animation. Here he is at -1. He travels over to the kale and has his snack, and then he travels back out. So to take this position versus time graph and come up with the velocity versus time graph for it, there's 2 steps we're going to follow. First, we're going to break the motion into smaller sections. Since there's 3 clear sections for the snail, there's from 0 to 3 seconds, there's from 3 to 6 seconds, and there's from 6 to 10 seconds. Those are going to be our small sections that we're going to look at separately. For each section, we're going to take the slope of the position versus time graph. The slope will tell us the velocity. And that's what we're going to plot for the velocity versus time graph. And in this graph, because his slopes are straight lines, it's constant, it'll be easy to come up with the graph. So let's start with the section from 0 to 3 seconds. So we're going to choose this section. We're going to pick 2 points on the line. We're going to use the slope equation from those 2 points to find the slope of that section. So first we identify that the points are going to be 0 and -1, and then 3 and 2. Those are our 2 points. Then we're going to use the slope equation, y2 minus y1 divided by x2 minus x1. We calculate our slopes, and since we have 2 minus a negative, remember that minus a negative is the same as adding, divided by 3 minus 0, and we get a slope of 3 centimeters divided by 3 seconds. 3 divided by 3 gives us 1, so our slope is 1 centimeter per second. That means that from 0 to 3 seconds, Sammy the snail had a velocity of 1 centimeter per second, and it's a constant velocity. So now we can create a velocity time graph, and for the first 3 seconds, we set our velocity at a constant 1 centimeter per second. Now we're going to look at the second section, from 3 to 6 seconds. I want you to pause the video, do the same steps to calculate the slope of this section, and then add the velocity to this graph from 3 to 6 seconds. All right, so the 2 points that I picked were the starting and ending point of the line, but you could have picked other points. I picked 3 seconds and 2 centimeters, 6 seconds and 2 centimeters, and I got a slope of 0 centimeters per second. You should get 0 no matter what points you pick. So Sammy has a velocity of 0 centimeters per second. That's when he's having his snack. So your graph should look like this on the velocity graph. Now we're going to look at the section from 6 to 10 seconds. So pause the video, calculate the slope, and add the velocity to the velocity versus time graph. All right, the points that I picked were at 6 seconds and 10 seconds, but those didn't have to be the only points you picked. When I calculated the slope, I got a slope of -0.5 centimeters per second. It's a constant slope because it's a straight line. And so my graph looks like this. He has a constant negative velocity. And that is your velocity time graph from your position versus time graph. Now we're going to go from a velocity time graph to a position versus time graph. So now we're looking at Sally. Sally the snail is also exploring the garden, and Sally starts at the kale plant. And Sally's velocity is shown in the graph above. So Sally starts at rest, then has a negative velocity, and then is at rest again. We want to figure out what the position time graph looks like. So let's talk about the steps that you need to take. This one's a little bit trickier. So we're still going to break the motion into smaller sections. 0 to 3 seconds, 3 to 6 seconds, and 6 to 10 seconds. One of the things that's a little trickier is that when you go from velocity to position, you have to be given the starting position, because where it starts on the position graph is not always 0. In fact, Sally starts at 2 centimeters. So we need to know that ahead of time because it affects how the graph looks. Once we have the starting position, the y value from the velocity versus time graph, so that's this value, is going to be our slope for our position time graph. So let's do this example together. So first, we're breaking the motion into smaller sections. We're going to look at 0 to 3 seconds first. And it says we must be given our starting position. So since Sally started at the kale plant, that's at 2 centimeters. So Sally's position is going to start right here. Next, the y value from the velocity versus time graph is going to give us our slope. So for this first 3 seconds, Sally was not moving. Sally was at rest. That means our slope is going to be a value of 0. So we will have a slope of 0 for the first 3 seconds. And so that's what this will look like on the graph. There we go. First 3 seconds, Sally is sitting at the kale. In our second section, the y value is -1 centimeters per second. That means that the slope for the velocity graph has to be -1 centimeters per second. So if I start at 2, after 1 second, I have to go down by 1. So it's a -1 centimeter per second velocity. That means my slope has to be -1. So for the next 3 seconds, I'm going to go down 1 and over 1, down 1 and over 1, down 1 and over 1. So I start at 2 centimeters. After 1 second, I'm at 1 centimeter. After 2 seconds, I'm at 0 centimeters. And after 3 seconds, I'm at -1 centimeters. So the slope has to be -1 centimeters per second. Our final section. So for our final section, our y value is 0. So Sally came to a stop again. The y value will give us the slope for the position graph. So since the y value is 0, Sally is at a stop. That means that this is going to stay at the same position and the slope will be 0. So it should be a horizontal line. Just like that. And that's the position graph from the velocity graph. So to summarize, from a position to velocity graph, break the graph into smaller sections, take the slope of the position time graph for each section, that's the value for the velocity versus time graph. To go from velocity to position, we're going to break it into smaller sections. Remember that you have to be given the starting position. This is your position at time 0. And then the y value from the velocity time graph will be your slope for the position time graph. And that's all for today.